Hello, my name is Matt, and for this code review, I will be reviewing an artifact from my CS340 client and server development course. The artifact I selected is a dashboard application that connects to a MongoDB database and displays animal shelter data through an interactive web interface. The project was built using Python along with Dash, Pandas, Plotly, Dash Leaflet, and MongoDB through a custom CRUD module. I selected this artifact because it demonstrates multiple computer science concepts in one project, including software engineering and design, algorithms and data structures, and databases. The purpose of this code review is to analyze the current implementation, identify weaknesses and limitations in the code, and explain the enhancements I plan to make later for my CS499 portfolio enhancement project. This section imports all of the required libraries. Dash is used for the web dashboard interface. Pandas is used for organizing data. Plotly is used for charts. And the custom animal shelter module handles MongoDB communication. The next section establishes the MongoDB connection and retrieves the animal shelter data. This section creates the database connection and loads the records into a pandas data frame. The object ID column is removed because dash tables cannot display MongoDB object IDs correctly. The dashboard layout is created using Dash HTML and data table components. This section builds the dashboard interface. It includes the title, data table, chart section, and map section. The layout allows the user to interact with the animal shelter records visually. One weakness I identified is that the database credentials are hard-coded directly into the source code. This is not considered as secure because anyone with access to the source code can view the credentials. A better approach would use environment variables or a configuration file. Another weakness is the lack of exception handling throughout the application. If the database connection fails or MongoDB returns invalid data, the application could crash. Adding try and accept blocks would improve reliability and user experience. There are also leftover development comments in the project. The fix me comments are left over from the original assignment. The functionality itself was completed, but I never removed the starter comments afterward. One enhancement I would make is improving documentation and cleaning up outdated comments so the project looks more professional. For my enhancement plan, I would improve the software design by separating the project into multiple files, instead of keeping most of the logic in one file. I would also move credentials into environment variables, improve documentation, add exception handling, and clean up the remaining development comments. These changes would demonstrate stronger software engineering principles including modular design, maintainability, secure coding practices, and professional documentation. For the second category, I will be reviewing the algorithms and data structures used in the project. The main data structure used throughout the application is a pandas data frame. The MongoDB records are retrieved from the databases and converted into a data frame so the dashboard can process and display the information. This section retrieves records from the MongoDB and stores them inside a data frame. The data frame acts as the main structure used to organize and process the animal shelter records. The dashboard also uses callback functions to update the table and map when the user interacts with the dashboard. This callback updates the dashboard table based on the filter selected by the user. The filtering part was completed during the original project, but I left some of the original development comments in the code. The map also updates when the user selects a row from the table. This callback gets the selected row from the table and uses the latitude and longitude values from the data frame to place a marker on the map. One issue I noticed is that the map uses positional indexing with ilog. This works as long as the data set always stays in the same order, but if the column order changes later, the wrong data could end up being displayed. A better approach would be using the actual column names instead of number positions. Another thing I noticed is the dashboard loads all the records at once. This worked fine for the class project, but if the database becomes much bigger, it could slow the dashboard down. A better version would only load the records needed for the selected filter instead of everything. For my enhancement plan, I would replace the positional indexing with named column references to make the code easier to read and less likely to break later. I would also improve the filtering logic so the dashboard only loads the records it actually needs instead of pulling the entire dataset every time. Another improvement would be cleaning up the callback logic and comments to make the code easier to maintain and understand. These enhancements would demonstrate better data handling, cleaner logic, and more efficient use of data structures. For the third category, I'll be reviewing the database portion of the project. This dashboard uses MongoDB as the backend database and connects to it through my custom CRUD Python module called Animal Shelter. The database stores the animal shelter records, and the dashboard displays those records in a table, graph, and map. This code shows the dashboard connecting to MongoDB through the CRUD module and retrieving the animal shelter records from the database. This section takes the records from the MongoDB and displays them in the dashboard table so the user can interact with the data. The dashboard also uses the database records to support the map functionality. This callback uses information from the selected database record to place a marker on the map and display information about the selected animal. One thing I noticed is that the dashboard mainly focuses on reading data from the MongoDB. The dashboard successfully retrieves and displays records, but there is not much direct create, update, or delete functionality built into the interface itself. Since this project uses a CRUD module, expanding the dashboard to support more CRUD operations would make the database functionality stronger. The dashboard also depends heavily on the database structure staying consistent. This section builds the table directly from the database fields. If field names change or expected fields are missing, parts of the dashboard may stop displaying correctly. A stronger version would validate important fields before using them. The map functionality also depends on certain database values always being present. If latitude or longitude values are missing or invalid in the database, the map could fail to display the marker correctly. Adding validation for location data would make the application more reliable. For my database enhancement, I would focus on improving how the dashboard interacts with MongoDB. First, I would expand the dashboard to support the CRUD functionality such as adding, updating, or deleting records directly from the interface. I would then add validation checks to make sure required database fields are available before the dashboard tries to display them. I would also improve the handling of location data to make the map functionality more reliable when records contain missing or incorrect coordinates. These improvements would demonstrate stronger database integration, better client-server communication, and a more complete use of MongoDB in the application. To conclude, this code review helped me analyze my CS340 dashboard project from a more professional software engineering perspective. The project already demonstrates several important computer science concepts including Python programming, MongoDB integration, client-server communication, data visualization, and interactive dashboard design. It also shows how different technologies can work together to create a full-stack style application that allows users to interact with real data through a web interface. For software engineering and design, I reviewed the overall structure of the application and identified areas where the project could be improved through better organization, cleaner documentation, and a more maintainable code structure. For algorithms and data structures, I focused on how the project uses pandas data frames to organize and process the animal shelter data. I also discussed ways the data handling logic could be improved to make the dashboard more reliable and easier to maintain as the project grows. For databases, I reviewed how MongoDB is integrated into the application through the custom CRUD module. I also discussed improvements related to CRUD functionality, database validation, and making interaction between the dashboard and database more complete. I think the artifact is a strong choice for my CS499E portfolio because it demonstrates multiple areas of computer science within one project. My enhancement plan is to improve the structure of the application, clean up the code, strengthen the database functionality, and make the dashboard more reliable and maintainable. These improvements will help demonstrate the skills I developed through the computer science program.